Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about functions. We're going to continue on our second week of functions, and let us go ahead and get started. I'm going to share my screen, and as usual, you can feel free to follow along on your own copy of the slides, or you can follow along with me as you like. Let's go ahead and bring this up. So last week we talked about the overview of functions and how to define them. We talked about the scope of variables. We looked at Python built-in functions. And now we are going to move on to talking about the fruitful functions and the stack. And we'll continue on this week to talk about overcoming some sticky points, which will be a bit of a review, but we're going to revisit some of those things that tend to be problematic working with the functions and perhaps emphasize things a little bit differently. And then finally wrap things up with taking a look at some of the advanced concepts at the third lecture this week. So then moving on, what is a fruitful function? We've talked about functions and how they return things. We're going to take a look at that in more details. So when we have a function, all functions return something. It's just some functions return none type. We've mainly seen functions that actually return something. Some functions we've seen print things. Printing and returning are not the same thing. Returning something means that that sends it back to the thing that has called it so that it puts it out into the main or whichever function has called it for that thing to capture that value. This is important to understand because if you print something, that means that the user can see it with their eyes. That means pixels on your computer screen turn colors that look like numbers and letters. But does that mean that that information has been sent back to the program? And the answer to that is no. And that's why it's very important that we understand the difference between returning something and not returning anything. And when I mean not returning anything, I mean returning none type, which is a null value. How do you return nothing? Well, you can't just not have something because the program needs to have something, but it means there's no information. And so the function could return nothing because it's doing work instead. It's displaying a picture, it's printing something onto the screen. And so those functions return none type because it returns no useful information. But other functions that actually return something, they return the value of an expression, then those functions return something. And so those are the functions that we call the quote fruitful functions, which is how your author calls them. And you will see this in your readings. So the functions can return various types. So we could return a float, we could return a string, we could return a Boolean. There's many different things that we could return. And as we'll see when we get into some of the data structures, it can also return the data structures. One thing we want to keep in mind is that functions can have many inputs, as many as you would like to put up in your parameters here in the inputs, but it can only return one thing. And so what we mean by when it returns one thing is that it can return one resolved expression. We'll have ways we can get around this as we talk about lists, for example, because you can pack multiple things into one list. You can return one list, but you can still only return one of them, and we still need to learn how to unpack that list. So those are some of the things we're going to be thinking about when we're talking about those fruitful functions. We're going to be taking a look at the thing that it's actually returning. And this brings us right back to the signatures. This here is the greet function. Once again, this function is a little bit different than the ones we've seen before. This is going to take the name and a number. We see that's going to take a string and an integer. So it will presumably take somebody's name, and it will take an integer, and it's going to return a string, and it's going to return a greeting. And we see here that what it's going to do is it's going to have this expression here that it can resolve number times hello. So this is an example of overloading, right? So we're going to have the multiplication operator overloaded for working with strings. So it's going to multiply hello this many times plus the name plus, again, the number times the exclamation point. So that means that this expression will have, if we have number equal to 3, hello, 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 the name, and then 3 exclamation points following it. And here's our function call to do this. We are going to greet Professor Thayer, the name, 3 times, so we'll have that. Now notice that when it returns this, this is going to concatenate all of these things into just a single string. And so our signature is indicating the string in integer is the input and that it returns a string right here. So functions can return various types, and here's an example of a string. We could also have a function that returns a float. Here we have definition of div of x comma y. This has 2 ints, so this will take 2 integers, and it's going to return float. And it tells us it's going to return x divided by y, which in fact we can see here, x divided by y is what is getting returned. So here we're going to do the famous 22/7, call our function and send up 22 and 7 for x and y respectively. And this will return the non-terminating decimal for the for pi in some truncated form of that, and then that will be sent into print, right? Because when this returns, it's returning into the print, and it will print out the value of 22/7, 3.14, and so on. Functions could also return an integer. Here we are going to have def of fdiv, or for floor division. We have x and y again. Our signature differs here. We're going to have 2 integers, and it's going to return an integer. It's going to perform that floor division, and we see that it's going to do x floor division with y. And here we're going to do 34 and 6. And so we will then get back a value that is an integer, because floor division always returns an int. You could also have a function that returns type Boolean. Why not? Nothing says you can't do that. So here we're going to have def of true. Why didn't I choose TRUE? A little too close to the actual true as in true and false. So I wanted to be sure to avoid that. So I just did something that sounded like it. And this is going to take a T. This is going to be a string for T. This is going to return type bool. Courses input string T to a Boolean. So this is going to return Boolean of T. This is a coercion function, the bool coercion function working on this, and we will do that for the T. Functions may have any number of inputs, but all functions return just one entity, as we were mentioning just a few moments ago. When you have a return encountered in the function, the execution of the function will terminate. We've mentioned this several times. This will become very important as we start talking about some of the if statements, because then you can have multiple branches, and we want to be sure that they all have the appropriate return associated with them. So once we hit any return, then the function will terminate. It also means that when the function terminates, that the variable table goes away. So only one return statement can be executed per run of the function, because if the function has terminated, then you need to call the function again in order to start it over. So that's why you can only have one return statement to be executed, although there could be more than one return statement in a function. You can only return one expression from each return statement. So if you attempt to return multiple items, you will return just one tuple, or we'll also see one list, which we'll talk about more than tuples, which is a data structure. Both of them actually are data structures. The items in the tuple will be one thing, and in terms of how Python thinks about it. So we'll learn how to extract the items in upcoming lectures, but still you can only return one thing. So you can have any number of inputs, but you still only get one thing for your output, which is the result of an expression, be it an int, a float, or whatever, or it could also be one data structure, which could technically contain multiple items in it, but because it's just one data structure, it's considered to be one entity by Python. The next thing I want to talk to you about today is called the stack. We see about the stack when we run a program and we have an error. So we can make the stack diagram to help us understand what's happening, and this is very useful for debugging. Have you made any mistakes in your programming yet? I'm sure that we all have. I continue to do so myself, and even to the best of us, we occasionally make a mistake at best, and many of us make mistakes all the time, and we have to make sure to remedy those mistakes. We also need to debug our code, and so this happens. To keep track of which variables can be used where, we can make the stack diagram. Just like the state diagram, the stack diagram shows the variables and their values. Remember, we talked about the variable table. The stack diagram also includes the information about the scope of the variables. Don't forget that we have the scope of the variables, the global scope and the local scope. That is, variables can be used out in main, can be accessed there, but they can't be manipulated. And then we also have the local variables, which disappear when the function stops running. Each function is represented by one frame or a box. The frame is the box for that function. The frames are arranged in a stack that indicates which one is being currently run. The stack diagram grows downwards such that the frame at the bottom is the most recently running frame. Now that might be a little bit difficult to imagine. So we're going to take a look at some functions and actually make some diagrams. So here's some simple code. This is taken from your readings. This is the print twice function. Here's the definition of it. So we're going to do def print twice, and we have some variable called Bruce, and we're going to print Bruce 2 times. So what Bruce will be is whatever you decide to make it when you make your function call. So also, your book tells you some things about the stack diagram. There are variables and parameters which are local, and we want to be sure to keep track of these. When you create a variable inside of a function, it is local, which means that it only exists inside the function. So here we have cat twice with part 1 and part 2. Cat equals part 1 plus part 2. See, it's adding them together. So this is for concatenation. That's why they're calling it cat. And now we can call out to the function of print twice with cat. This is an interesting example because we see that we have a function call inside of another function, which is a totally legitimate thing to do. So it's useful to consider what exactly this is going to do. The function is going to take 2 arguments. It's going to concatenate them together right here in this line because we have part 1 plus part 2. That will be stored in the variable called cat. And then we have the print twice function call of cat. So whatever cat equals, that will be sent out to the print twice. So that thing that is sent out to be printed will become Bruce. The variable Bruce will become that. And the 2 printings will come from these lines right here. So then this function will terminate. It doesn't return anything, so it returns none type, right? All functions return something, just some functions return none, and the type of the thing that functions return would be none type. And the control comes back over to this location here, but that so happens to also be the end of this function. We see that this one does not have an explicit return, so this one also has an implicit return. It returns none also, so the type of this is none. So here we have some examples of some things that we could run through this. And so we have line 1 is being set to bing tittle, and line 2 is tittle bang. So if we do cat twice of line 1, line 2, what will the output be? Well, let's trace it through. Line 1 is bing tittle, and line 2 is tittle bang. So when we make this call, we send bing tittle to part 1 and tittle bang to part 2. So now it's going to concatenate those together. So bing tittle, tittle bang. And then we call the print twice function with cat, which is bing tittle, tittle bang. and we call that function. So now Bruce becomes bing, tiddle, tiddle, bang. And we print it 2 times because that's now what Bruce is equal to. And so then we get this output as we see it here. It's useful to get in the habit of walking yourself through actually figuring out what you think the functions are going to do before you actually run them. It's good to run them too, but make sure you think through how the program is working. Notice that when cat twice terminates to the variable cat is destroyed, and if we try to print it, we get an exception, otherwise known as an error. So don't print things that whose scope is already gone. So now I think it would be helpful for us to actually put all of this into the stack diagram to keep track of what's what. So here I brought some of the code over for us to just use as reference here, and this is our stack diagram. So out in main, which is the part that's not inside the functions, we're representing by main here, we have this box, and this is where things initiate. We have line 1 is bing tiddle, and line 2 is getting the value of tiddle bang, because we had done those variable assignments and we can see them right here. Then we move from there into a function. So we make a new box. So we have a function call to cat twice, which we have right here, cat twice, right? And then we go into our next space. The reason why we separate this is because remember that functions only have a scope when they are running. So once this is over, we'll want to erase this, whereas main persists even when functions run. So here we have part 1 will get the value of bing tiddle, and part 2 gets the value of tiddle bang. How do we know those variable assignments happened? Well, it happened during the execution of the def line, right? So once you call the function, part of the function call is to execute the def line, which has those implicit variable assignments. Don't forget about that. So we have bing tiddle and tiddle bang being assigned to part 1 and part 2. Then we have cat being assigned to part 1 and part 2, which then puts those 2 things together. Now we need to start another box in our stack, because now we have a function call to yet another function, that print twice function. So we're going to make a box for the print twice, and we're going to now keep track of the variables that are in there. So in that one, we have the Bruce variable, right? And Bruce variable is going to get the value of bing tiddle tiddle bang. It's the input parameter, if you remember from this right here. And so this is our stack diagram. This is distinct from the variable table because it separates out the various areas or scopes of our variables. We have the scope inside the print twice, the scope inside cat twice, and the main. Traceback errors are related to the stack diagram. When an error, otherwise known as an exception, occurs, Python will provide an error message to you. The traceback shows a list of the functions. It tells you what program file the error occurred in and the line of the code that caused the problem. It traces back the functions that caused the problem. It will be in the same order as the stack from bottom to top. It shows the current line of code where the error was noticed, and it follows the stack trace back, which is why it's called the trace back. All right, well then, thank you so much for joining us. I hope that this has been helpful in illuminating a little bit more about the functions, and we look forward to chatting with you the next time. Thanks so much. Bye-bye.